let us understand about templates. Before going to templates, let me talk little about function overloading. Function overloading. We have studied this concept in the course of C++. See, I want to add two numbers. I want to call a function add. Function overloading says that we can have same function name, right, but they should differ in the return type or the data type of arguments or number of arguments. Meaning, I can have a function like this, int add with int comma int. I can have a function like this, or you can have a function int add int and int. This can be also function overloading, or you can have float, or maybe still int. Let us have it int only. Int add one float and another int, or another int, this one as float, or both can be float, right. Use all these using same function name add, right. This is function overloading. You are trying to use the same function name, but the data types are differing. Okay. Either the data type of the parameters is differing, or the number of arguments is differing. When both are integer, here there are 3 integers. If you observe here, these two, the number of arguments are differing in these, and if you observe first two, the data type of the arguments is differing, right. This is function overloading. Okay. So, we are using same function name there. Now, in that scenario, if I want to write a program, to add, I may give input add 10 comma 20, okay, and also I may in my main I can give add 10.5 comma 20.3. So, I want this both to work like this, x equal to y equal to. I want to write. So, obviously, you will go for function overloading, where you will write two functions. See, you will write here integer. This will corresponding function will be integer add int a comma int b will be the function call. Sorry, this will be the function call where you will be writing return a plus b. Okay. Also, you have to write another function int add with float a and float b, and you write return a plus b. See, to add, if you observe, though I am using function overloading here, I have to write the function body for first type, which takes both integers, second type, which takes both float. Suppose somebody asks you to write one float, one int, one float. I want to add something like this, add 10 comma 20.3, or I want to add 10.5 comma 20. Now, if I want to have this maybe some k, p, some variables, right. If I have same function 4, I want, my end goal is to, I am passing two numbers as input of different data types. Okay. They should be added, and the result should be printed to me, or result should be given to me in some variable, right. So, if I want to implement like this, see, unnecessarily, or we are increasing the code size, though they differ only by the data type. Okay. All these four function calls, you have to implement 4 functions here. You have to write 4 function body. This is first function body, this is second, then you should have third function body, where one is int, other is float. Then you should have another function body where one is float, other is int. Like this, you have to write 4 function definitions, or 4 function body you have to include in the program for this to work. So, the program size is very big here, but if you observe what we are trying here, in all these function calls, ultimately I am just adding those two numbers, but they are differing using the data types. Since they are differing with the data type, we are writing 4 functions with same name. So, this logic we call it as function overloading. But what is this? Why are we studying templates today? Right. If you see, to call these 4 functions, or to add two numbers which belong to integer, or both of them belong to float, or one int float or float int, right? You are writing 4 functions, but templates makes us to write code such a way that you will write only one function which will work for any given data type. Okay, you will be writing one function which will work for any given data type. That is what we use templates. Okay, so templates helps us in writing generic functions. In generic functions, meaning you will write only one function add. You will write only one function add. Okay, you will write your logic here. Return some. I am again just writing in rough. It is not exactly like this. Okay, something will be here, some type will come here. You will be writing one generic function like this, which will take inputs of any given data type. If you are sending 2 integer, it will treat these 2 as integers and add them. If you are sending 2 float, it will take both of them as float. So only one single function is taking care of adding values of different data types or same data types. Okay, so all these 4 or maybe any other values you want to include, that can be taken care by only one function. Those functions are called generic functions. So templates is the concept which helps us in creating generic functions. Why we need generic function? Instead of implementing 4 different functions using function overloading, you can write a single function only. Your code becomes very small, it becomes very easy, there is no scope for mistakes, right? Only one function will take care. Suppose maybe if you are writing 4 functions, in the previous step I told you that when you are implementing function overloading, you have to write 4 different functions. Though it is addition only, you have to write extra lines of program. Maybe there is a chance you may make some mistake in while adding one int and one float, you missed something. Okay, addition is a small logic, but if you have very big functionality, you may make mistake there. Unnecessarily same thing we are repeating different times. Logic is same, no. See, I am ultimately returning a plus b for addition of 2 numbers, but unnecessarily I am writing 4 different function bodies or function definitions, right? Using the concept of templates, you can write generic function. These generic function will take input of any data type. Okay, they are generic data types. You send int, it will take. You send int float, it will take. You take float int, it will take. It will work for everything. So templates is the concept which helps us in writing such generic functions. Let's go deep into this and understand how to write it, how to create templates, how to write such generic functions using templates. Right. A template is a simple yet very powerful tool in C++. Okay. It is very simple yet powerful tool in C++. The simple idea is to pass the data type as a parameter. In this example which you have seen, okay, in that function add, right, we are writing like this: add int a comma int b. From main, how are you writing this? From main you are simply writing add some x comma y. See, you are passing only the values. In templates, you have to pass the data type as the parameter. That's it. You don't need to write the same code for different types. Simple code is enough. Okay, you need not write for float one logic, 2 integer another logic, 2 float another logic, 1 int one float another logic. You need not write that same code. Okay, just to pass the data type as the parameter, that generic function will take care. So we have 2 more new keywords here. Template is the keyword which we use to create a template, and type name is another keyword. Type name is another keyword. Sometimes since we work with C++ object oriented programming, we will also have class as the type name. Okay. So templates in C++ allow you to write generic and reusable code by defining functions or classes that work with any data type. It means we can have function templates and class templates. Okay, right? So they are specially useful for situations where you want the same functionality to work across multiple types. I want to do addition of numbers, but it should work for any given data type, float, double, int, char, for anything it should work. For those things we use templates. let's see how template works. Okay, we'll see an example, then we will try to understand the syntax and the mechanism of creating templates. Okay, so templates are expanded at compile time. It is like macros. I think you are aware of this hash define x and 10. Okay, this is macro. We define it above main, right? What is the functionality of macro? During compile time, in the main program, wherever there is x, compiler will replace that x with 10 during compile time and then evaluate that expression. Okay, so templates are also same like that. The difference is that the compiler does type checking before template expansion, right? So the idea is simple. Source code contains only function, but compiled code may contain multiple copies of same function. Let's see this example. Observe the example here. Anyhow, it is directly written here, but we'll see the syntax and understand it. See, in my main, this is my template definition. To define a template, you have to use the keyword template. You have to use the keyword template. Then in this less than greater than symbol, give type name. Type name is also a keyword. Type name T. You are creating an object of type name T. Then that T is the return type. Function name is add. Okay, what is the data type of those variables? It is also T, x, comma T, y. That's it. I want to return here this x plus y. Okay, if you observe here, I am trying to create a user defined data type kind of. Generally, what should I write instead of this line? We will be writing here int add of int x, comma int y. This we have to write generally in place of this statement. But what I wrote here, instead of int, this int, I kept t, t and t. What is t? T is a template. So this is a fixed statement, you have to write always. Template, type name t. Okay, so this function add, which is written like this, t add t x, comma t y. So if you are passing integer, its meaning is like this, int a, int x, comma int y. If you are passing float, it is float add float x, comma float y, right. So first we define this statement like this, template type name t. Then like you write this function, you are writing instead of int, you are writing t or tx, that is int space x, t space y. Then write your programming logic as it is. Now you see here, I am calling the function that here it is my max. When you are calling the function, you have to also pass the argument like this. So when you are calling that function add, in my case, in that example which I am taking, you have to write like this, add integer values, I am giving 3, 7. Then again write add float values, give here 3.1, 7.1. So when this statement you are writing, this function is invoked like this. See, when I wrote int 3, 7, this compiler generates this code. See, compiler internally generates and adds below code, int my max, int x, int y, return. When you wrote character here, it is creating char my max, char x, char y and return. Okay, that is automatically taken care. We are not worried about it. But your program is only this. So you can write here my max of float, in bracket you can give 7.1, 7.2 like this. This body will execute that. Okay, so this is how a simple example to show how template works, right. It will create a copy like this internally while executing, but for your naked eyes you are writing only this much. That's all. A kind of smart programming where you are writing very small code. This generic function is taking any kind of input and adding and or doing whatever operation you are specifying, right. So that's what we give. I hope you got little syntax of that template. We will see, right. So there are generally two types of templates. One is function templates, other is class template. So till now this is a function template. Okay, means function overloading. I am trying to overload function using a template. Okay, same way we can do it for class. We will see it later, right? So templates are of two types. See, templates allow you to define generic classes and generic functions, thus provide support for generic programming. So what is generic programming? Is a technique where generic types are used as parameters in algorithms so that they can work for variety of data types. Right? So there are two types, one is function template, another is class templates. Let's see about function templates, right? So till now I have been talking only about functions because it is easy to understand. The syntax is very simple: template, type name, t. You have to give that in angle brackets like this. You have to use the keyword template, template. Okay, here you have to give type name, and you have to give a variable. It need not be t, it can be some anything. You can put k also here, and you can write here k function name fun, then kx comma ky. Okay, but since it's standard in all textbooks, you will see they are using t because template stands for t. So we write it t notation always, and open and write the normal function body. This is the syntax of creating a function template. Okay, right? We have to use angle brackets. Instead of writing multiple versions of a function for different types, you can write a single function template that automatically adapts to data types of arguments passed to it. It will work for any given data type. Okay, so a simple just a small program for addition of two numbers. Okay, small program for addition of two numbers. But again, this is with class. Okay, this is with class, but you can maybe this example. Let's see. Yeah, this one basic one. You see, program to find maximum of two numbers. So first for that I am defining a function get max. So see, I wrote a this is fixed statement. Always you should write this template, type name, and t. This is fixed statement. Then you have to write that t and get max is my function name, and it is taking two variables of type t and type a of type t, b of type t. In this you write your normal logic like this: return a greater than b, question mark a, then b. And in main, you see, in the main I am having two variables x equal 10, y equal 20, double a equal to 5.5, b equal to 7.3. Okay. So when I am saying see out max of x and y, get max x comma y, it gives the answer. You give get max a comma b, it gives the answer, right? So this is a simple program to demonstrate how function templates are used. Okay. So this is the fixed line, and this is the syntax of creating a function template, right? Let's see more examples. See, bubble sort using function templates. Okay, I anyhow I have written this normal logic, but just to show you, somebody asked you to implement bubble sort using function templates, you can see this. So start from main here. Main is there, int a of 5 equal to values are there. I am calling the function bubble sort. See, when you are calling the function, you have to give this type. When you are calling the function, you have to give the type. So bubble sort, you are giving int, okay, a comma n, right? When you are sending this, so this function is called here. Again, this is an example of class, but still bubble sort we are using this function. So type name is replaced with class here. Okay, you can even use class here instead of type name, right? Templates class t void bubble sort t of a and int n, t of, so t is of type array. So if I am sending integer array, this t will take integer. If I am sending floating point array, this t will be that particular data type. This is normal logic of swapping, the sorting logic, right? This is just to demonstrate how we are using this. Let's see. Now can we pass multiple arguments? Can we pass multiple arguments to function templates, right? So see, the template, previously I was doing this. I said template, you were writing type name t only. But if you want to pass more arguments. I want to add one integer and one float, how to do that? Both integer okay, but one integer, one float, how to do that? Then you have to extend this type name t, comma type name, right, u, or type name u, like this, type name t, type name u, you can give. Then write the function, but what will be the type, what will the return type of this function, that I don't know. You can mention it, you can mention either t, you can write like this, t of fun of, that this type is t, no, t of a comma u of b, like this you can write the logic. Okay, you can create two type names, t and u, meaning this a belongs to type t, b belongs to type u. Return type, you want t, you put t, you want u, you can put u, or you want some nothing, you can put void, and write your actual logic here, right. So you can have multiple data types as arguments, right. So this is the case where I want to add integer and another floating point. Okay, so why here it is class, why not type name, right? You can use class or you can use type name, both are valid. That's what we said here, right? The second keyword can always be replaced with the keyword class. You can write either type name or class, anything is fine, both will work fine, nothing to worry that, right. So this is just an example to demonstrate that you can pass values of two different data types. Even I can have like this, see, template, okay, maybe I can write there class t1 comma class t2 comma class t3, okay, sorry, this is in this brackets, not round brackets, like this. Then you can write void some function add, where t1 x comma t2 y comma t3 z, and you write your normal logic whatever you want to write. So whenever you call the function t1 with three different data types, it will take. So one can be int, float, this can be int, this can be int, this can be float, this can be float, this can be int, anything is possible. One function is enough. You just tell I will be sending three different data types. In this, these two can be same or different. If all three are same, you just write t only, no, why all these three are required. If all three are same, you can simply say class t like this, and here all you can define t of x, t of y and t of z. That is why we use templates more when you have to play with same data type, meaning all those variables which I am playing with belong to same data type, okay, but logic is same, okay, variables are more, but the data type of those variables is same, then you can go for function templates. So this is just to explain you that you can have multiple data types as inputs to a function. Okay, so this will simply say a value is 15 and b value is 12.3, like this it can be exist in the functions, right. Next, function overloading in templates. Okay, so how to overload function template itself, right. We already studied that. We are trying to we are trying to implement function templates to avoid the problem in function overloading, correct. Function overloading exists. We are saying there are some drawbacks, so we are moving towards templates. These templates also can be overloaded. Okay, how? Let's see this. See, I am having a function fun. So template class x void function x of a. That's what we have to write. No, we have to write void fun, the template type and the variable name, and you write your business logic here. Then same, I am having template class x and class y, void fun xb and yc. See, I am calling function with 10, this block is executed. I am calling with 2, this block is executed, right. We can even overload functions, okay, or function templates. Okay, we can overload function templates, right. So this is about function templates. I hope you understood this. So one more this example we will see, addition of two numbers, right. Class t, t add t ampersand a ampersand. You can even send pointers,
Okay, you can even send pointers to the function. Here it is written ampersand, but it's not actually implementing that. So this is this is not required. This is the logic. So you can call two values that will be added, right? This is about function templates. One last topic here. What is the difference between function overloading versus templates? Okay, very important point here. What is the difference function overloading versus templates? First difference you understood, code is repeated in function overloading because only data type is changing, data type is different, whereas here in template we are writing single one. Okay, in function overloading unnecessarily I am writing 4 different functions, in templates I am writing only one function. The most important difference and the actual difference between both is, suppose see an example, I have int add, I am taking int a comma int b as parameters, and here I am writing cout largest is. Okay, I am writing a greater than b question mark a colon b, like this I am writing inside this add function. Here I have another function int add float a comma float b. Okay, here I am writing return a plus b, right. These two functions if you observe from my main I will be calling add some x equal to, just let me erase this, some x equal to add 10 comma 20, it will give some value to me x in x. Here you can give some y equal to add some 5.5 comma 6.5. For your naked eyes, if you see, I am having two functions with same name add and add. We call this as function overloading. We call this as function overloading, right? Because add, I am giving two numbers, I am giving two numbers. Here also int, float. Very clearly this is function overloading. Immediately you will think why not apply templates. So you will write template for this. What is the template logic? You will write that template statement, template, just a second. You will be writing the template logic, template type name t, then you will write t add ta comma tb. You will write this. What will you write here? You will write return a plus b. Okay, you understood that from this, that this is function overloading. Why to write two different blocks? Okay, right. But here you are trying to create a generic template, generic function using templates. But inside this integer addition, it is actually doing something else. Though the name of the function, the arguments, it is clearly matching with the concept of function overloading, but inside this integer I am doing something else. Inside this float values I am doing something else. Okay. So, function overloading cannot be directly converted to function template like this. You are having a program which contains function overloading, you cannot convert them directly to a template like this. You can override the function overloading, or you can remove the concept of function overloading from a program using templates only if the body of each function is doing same thing. The body of each function is doing same thing. Only you can generalize them, no? Only then you can generalize them as a template. Otherwise, how will you generalize? This add with two ints, it is doing some job. Add with two floats is doing some other job. I cannot generalize them as a template. This is very important point. So, not blindly we cannot convert those function overloading function definitions, that overloaded function definitions as a template. You can convert those overloaded functions into templates only if the body of each function is doing same task. Okay. If it is returning AB, here also returning AB, then you can convert that to a template, but not if they are doing some other task inside the function, right. So, this is the difference between function overloading versus templates. You can convert only those functions which are overloaded with same function name and different data types, but also they are doing the same task inside each of the functions. Those can be generalized as templates like this, otherwise we cannot do that. Okay. So, this is about function templates in C++ or in specific templates in C++.